So about telescopes, again, we talked about refracting telescopes. Refracting telescopes use just lenses. Reflecting telescopes use just mirrors. Well, one thing that comes up is that if you're looking at telescopes, that in order for the mirror to focus properly, it has to be the right shape. So your shape of the mirror has to be a parabola. And so the light is all brought to a focus like it's supposed to be. If it's a spherical shape, it's out of focus. Now the thing is that a parabolic shape is vastly more expensive to make than a spherical shape. Spherical shape mirrors can be made in an automated fashion, whereas parabolic is much more difficult to do that. And so early part of the 20th century, they realized that it didn't work so well, so they had different strategies around that. One used very long focal length mirrors, in which being slightly out of shape didn't really matter as much. And the other was a fellow named Schmidt comes along and says, why don't we instead use the cheap spherical mirror that doesn't quite focus right, but we're going to correct it with a glass plate. So the light comes in, and it's like putting glasses on your telescope so everything comes to focus properly. And so this gave rise to the Schmidt telescope. The most famous Schmidt telescopes are what we call Schmidt-Cassegrain telescopes, in which the light comes in, hits a mirror, comes up here, hits a mirror, goes out the primary here, and there's a glass plate on the front that corrects for the mirror being the wrong shape. Latter part of the 20th century, about 1970s or so, 1970s, 1980s, the Schmidt-Cassegrain telescope became sort of the go-to telescope for amateur astronomers because you had a small, lightweight, powerful telescope that you could do, whereas a large Newtonian telescope, the same diameter Newtonian telescope would be twice as long and very difficult to carry around and very heavy. The mount would have to be heavier too. And so this became kind of the go-to telescope. I want to say a word about George Ellery Hale. I'd mentioned him before. He's a very interesting person in astronomy. We often think about astronomers and astronomy class as just a list of facts, but I want to point out there's people involved. And George Ellery Hale is one of these people that he started studying solar astronomy actually before he went to college. His dad was somewhat wealthy and bought a telescope. He set it in the backyard and started studying solar astronomy. Did so as an undergraduate too. Went off to get a PhD, got a professorship at University of Chicago, and while there realized that at the time the only big telescopes that were available were in Europe. The United States was a fledgling in terms of astronomy. So all the big telescopes were in Europe somewhere, not in America. And so he really wanted to have America as a major power. So he got the money from Yerkes to build the observatory, the Yerkes Observatory here, which had spot for the world's largest reflecting telescope. We already had the United States actually had the lens for that. A fellow named Alvin Clark built it for the World Exposition just to illustrate how powerful American technology was. We had this giant lens, and so Hale got the money to make that into a telescope right there. And then there are a couple of smaller telescopes here, living quarters for astronomers while they're staying at the observatory to work here, a library, laboratories, office buildings, and so forth. Yerkes Observatory remained, in fact, when he had it built, was the world's largest telescope and remained a research facility up until about 5 or 6 years ago, when University of Chicago realized they couldn't actually support it and they shut it down. And so it was bought by a developer that was going to turn it into a resort, and then the developer went bankrupt, so right now it's sitting idle. and is a piece of world-class history for astronomy. But Hale realized at the time this was a very bad place to build an observatory right here in Wisconsin, right near the Great Lakes. It was close to the University of Chicago, great for astronomers, but a terrible place for an observatory. He actually probably suffered from what today would call bipolar disorder because he got severely depressed, thought his entire life was a failure for having the world's largest telescope built in a bad place where it was humid and cloudy a lot. And so he got kind of better, moved out to California, where he started researching where would be a better place to build an observatory. And so while there, near a small town at the time of Los Angeles, up in the mountains, Mount Wilson, he found dark skies, fantastic place, not too terribly far from metropolitan area, so astronomers could get to it. And he had a solar observatory built up here, got money to build a telescope 60 inches in diameter here, and that was way bigger than the 1 meter telescope here. The problem is the 1 meter Yerkes refractor, the world's largest refractor, was the biggest you could build a refractor. So this was going to be a reflecting telescope, and so much bigger. So he got the thing built, got the money to do this, and then realized at the time, once he got it built, it was so much better. It was showing him so many things that, well, gosh, he realized that an even bigger telescope would have shown more, and he got depressed, was actually institutionalized for a little while, got better, recovered, got money together from wealthy businessman in California of Hooker. Hooker gave the money to build a much larger telescope, 100 inches in diameter, the Hooker reflector. And so with that telescope, this is when they discovered the expansion of the universe. This is where they discovered what galaxies were. They discovered all kind of things, the size, structure of our galaxy. So all of a sudden, this was a major step forward, and it was the world's largest telescope for a while. So it was the world's largest telescope, slightly larger than the one that was built shortly before it, actually in West Texas, which was the largest for a little while. But once again, he fell into depression, realized, that this was not great because Los Angeles was growing and becoming a major city. And so he realized the skies were getting bright at Mount Wilson Observatory, and so this was really not the best place to build it after all. So again, he fought off depression, got better again, and said, we need to find a better place. He researched across California, found a place that was going to be dark for a long time, Palomar Mountain. And so he got money together to build a monster telescope at Palomar Mountain, which now bears his name, the Hale Telescope. Got money to build the mirror 200 inches in diameter, so vastly larger than anything that had come before. And so the Palomar Telescope was going to be the premier of the world. And so this was a major step forward, and got the money to build the mirror. They fabricated the mirror, had the press here. The mirror was built in Pennsylvania. And so they poured the mirror as glass, new kind of glass that would not expand or contract with temperature, something called Pyrex. And so got the mirror built. And when they opened the oven where they'd cast the mirror, they found bubbles in it. It takes a year after they cast it to cool it down to when they open it. And so the mirror was ruined, and they had to redo the whole thing. Finally got it done, shipped it to California, and then the Japanese attacked Pearl Harbor. And they were actually afraid that possibly the Japanese would then attack the West Coast. So the mirror was put aside for the duration of the war. Now, he didn't actually live to see that part because he died right before that. And so but they did continue, and then after the war, the mirror was installed, and it saw first light. This was and they named it the Hale Telescope. It is so huge, the astronomer actually sits in the barrel of the telescope. Light comes past, so the light will come past, hit the mirror, and he can sit in prime focus. He or she can sit in prime focus. Well, actually, nowadays there's a camera there instead of observer, but that became the world's largest telescope. I collect stamps, and so they actually issued a stamp in its honor in 1948 after it went went live. The Russians obviously couldn't let things stand, so they built their own giant telescope. The problem with this telescope was the Russian telescope is not quite as good as the Palomar telescope, because the Russian telescope, when it bends over, the structure sags a little bit, so it'd go out of focus. The other thing is the sky there was terrible. You had bad sky conditions all the time, so that telescope was also not the best thing in the world. So even though it was bigger than the Hale Telescope, astronomers typically still regard the Hale Telescope as the biggest and best. And so that sort of set the stage. For the longest time, this, in fact, was then the largest telescope on Earth. So why do we want a bigger telescope? It's not just bragging rights. Remember, light acts like a wave. When a wave goes in an opening, it spreads out. So if you have a small telescope, the light spreads out more than with a big telescope. Remember, light waves are small. The closer your telescope is to the size of the light waves, the more effect it's going to have. And so what that means is that as your telescope, the bigger the telescope, the less spread out light is. So what we have here is, for example, two stars. In a small telescope, the light overlaps, and it's hard to see you have two stars. But in a big telescope, you can see that you have two stars. This effect is called resolution. The better the resolution, the smaller thing that you can see. The other thing is, the bigger the mirror, the more light it brings in, and so the brighter things look. So a big telescope makes things sharper and brighter. And that's why we want a big telescope. But the big problem here was the Palomar telescope was close to the limit of what was physically possible technologically. The Russians showed that because they built something bigger that didn't quite work right. And so what that means is that we were at the limit as to how big we could get. And so something else had to give way to start getting bigger telescopes. And so that's going to be the next topic.